Can I solve problems using exponential growth and decay, right? It'll be both. And you guys, here's the math you will almost certainly, you will absolutely use someday. And interest. So we're making money. So can I solve problems using exponential growth and decay? Yes. And also interest. We will by the end of today. So we already know.
I think we do that.
Anyway, we already know, guys, we know my basic model for exponential growth and decay, b to the x, but there's a little a, the coefficient there, right? That's going to stay the same. We are going to assign, for word problems, values to these. So x stays the same, y is just whatever I want out of my equation.
Is there never going to be an h and k in these problems?
Yes, later on. Right now there are, but we're going to call them 0. So on this right now, no, and not on interest, but yes, eventually. Like you just asked, where's the minus h and the plus k? They're there in these problems, but they're both equal to 0. So for our purposes, they are gone. When you're doing these word problems, you just have to really For those of you watching at home, we just cured quick up. So we can understand it. Right. So, when I'm doing word problems, do it the same way, guys. Riley, go through your word problem. Underline if you do. Oh, sorry. I have it every single time. I'll never get it. No, you're not. Go through, guys, underline things that are important, assign them variables, and plug them back in. So A is always going to be my initial amount. The amount of what will change, in this first problem, it's clearly computer viruses. Listen to this. The initial amount, when we're dealing with interest, so when we get to dollars and cents and compounding interest, it has a different name. It's called principal. So if I say I'm going to put $4,000 into an account, that means my principal is $4,000. That's my initial amount. Okay, so we'll change that to P for principal later on. You'll see that. But right now, initial amount. B then is, and it stays the same, is my rate of growth. We'll just call it growth rate. Growth rate. Now that can be a growth rate that is smaller than 1, and so that would be decay. We'll just call it growth rate, growth/decay rate, if you want to write that. So then x is always just going to be an amount of time, and that's going to change. Sometimes it's in years, sometimes it's in months, but it's just an amount of time. Most of our problems will be years, and then we'll change out when we get to y. So in 1996, grade 90s, there were 2,572 computer viruses and other computer security incidents, right? During the next 7 years, the number of incidents increased by about 92% each year. So this is very, very similar to problems you'll have, both on homework, quizzes, tests, everything. 2 parts. Part A, write a model that shows how we do this, and then use that model in part B, right, and find me how many incidents there were in 2003. So my equation is always just going to be a y equals, right, a times b to the x. So what is a here? 2,573 computer viruses. That's my initial amount. So I have that many to start with, okay? And then it's telling me that they increase by 92% each year. So is this growth or decay? Growth. So my answer needs to be bigger than 1. So I can't just put 0.92. What do I actually need to put there for my b? 1.92, right? So 1 plus 0.92, which I'm going to erase and rewrite as 1.92, right? Because I'm taking the original 100% and growing that by 92% each year. If I just did 0.92, this would not be exponential growth. It would be what?
Exponential decay.
Exactly. Between 0 and 1. I want to make sure we're growing. So that's just raised up to the x power. That's time. X here being measured in years. So there's your model. Let's just plug it in. What am I going to plug in for x to find out how many incidents there were in 2003? 7. Very good. So y equals 2,573 times 1.92 is 7. You tried it in your calculator. Look away. You can't try. This my calculator. Right.
Actually, put Candy Crush for music.
Now it's like look like Candy Crush.
Going to go which song?
Put it in the calculator.
Oh. Actually, that was just
This is a terrible walk.
It's a big number. Yeah.
It's not a video, it's just audio.
Waiting for it. Yeah.
Ashton, what'd you get? On your phone. What'd you get on your phone?
Really wanting.
You were using it as a calculator, right? Put it away. Guys, the phone should go away. I don't know, is it? What did you get? 484. Okay. Who got 484.7 something or something like that? Right? You have to round to the nearest whole virus. Can you have half a computer virus? No. When guys, a lot of these things will be dollars and cents. What do you think you're going to round dollars and cents to? Not dollars, because we deal with, in America, we have cents. Yeah, to the hundredth spot, so tens and then hundreds. And after that, just round to the nearest cent, right? So that's always true, right? Some people would say, yeah, but that's 0.08. Why can't I round that to 0.1? Because I can have 8 cents. Why would I give you 2 cents to put 0.08 is 8 cents. You'll see it. Guys, this is where your labels become important and your rounding. If you tell me there's 0.75 computer viruses that happened in 2003, I'm going to have to take probably my log line. I'm going to have to take off points. Same with in 2004, there were 500 Amazon tree frogs in Brazil, and then if you tell me that in 10 years there was half a tree frog, yes, you could argue that the tree frog got sliced in half, but I won't take that as an answer. I need whole tree frogs, right? So, that is your answer. Here we go. A new snowmobile. Because we're all looking to buy snowmobiles. Useful math, right?
yeah.
A new snowmobile costs $4,200. That's a really nice snowmobile. The value of the snowmobile decreases by 10% each year, right, in equation. So let's identify A, B, and X here. So what is A? 4,200. That's my initial amount, right, guys? Snowmobile originally cost me $4,200. Growth rate. 10%? So it's decreasing by 10% each year. So it's, well, you could say it's not increasing by 90, but what is that when you multiply by? So I'm decreasing by 10%, right? Which means that each year.
It's not really my fault.
It was my fault.
I'll take the blame. It's like Akon. It was
Right.
possible. Blame on me.
Can you get behind there, take some minutes, you can do it?
No, you no longer. So if I'm taking away 10% each year, how much am I left with each year? 90%, okay? So if I want to decrease by 10%, I could say my growth rate is 0.9. Not my growth rate is 0.9, but my B term is 0.9. If you did 0.10, you then have to take away from 100, right? Because if you times by 0.10, you're going to get a tiny number, right? Yeah. Well, 10 to the third, and then, yeah, I think it was like $4.2. $4.20. You need to do it by 0.9. So X, guys, X is just years. You're almost always going to have to change. Because if it's growing by 50%, you actually need to multiply it by 100%. Right? And if it's decreasing by 50%, you need, well, that's not true. It's decreasing by 50, it's exactly 50. That's your only reason. But 1 minus 0.1. So, write an equation, y equals, what's first? Good, what's first? 4,200, that's my A term, good. And what, Lucky?
Then your B term.
B term, which is?
90.
0.9. Right?
Yes.
0.90 if you want to raise to the x power. So, on your own, y equals 4,200 times 0.9 raised to the third power. How much is this snowmobile worth in 3 years?
Quite a bit. Did you wait for everyone?
Yeah, really.
$3,061.80.
Oh my gosh.
That's what I was thinking.
Yeah, good question. So, why did I add 1 here, right, to my 0.92? Why did I not add 1 here? I actually took it away from here. Guys, if you wanted to think about this as, so A, and then your B term is always 1, and you can say it's 1 plus your growth rate, right? So 1 plus G, so it's always 1 plus, right? So if I'm doing 1 plus, here my growth rate was positive 92%, plus 0.92. So 1 plus 0.92 equals 1.92, right? 9 has the start, if you want 92, not 2, 9. If I wanted to do my decay here, all right, so here my growth rate, it wasn't positive 10%, right? We said it's decreasing, so it's negative 10%. So if I want to do 1 plus G, okay, that's 1 plus a negative 10%, which is 0.9, right? Yeah. So if you want to think about it always as 1 plus, and then you need to figure out if you're adding or subtracting, that's fine. Does that make sense to you? I did, right? I just subtracted from 1 instead of adding to 1. So on my snowmobile, I decreased by 10%, so I took 10% away from 1. On my increasing, I was increasing by 92, so I added 92. The 1 is there in both of them, right? There's my 1, there's my 1. In decreasing, in exponential decay, I subtract. In growth, I add. Cool? And we'll do some more. Let's do some more. And in decay, I subtract. Right? Good. $3,061.80. Alright, I need to erase a little bit of this because we need to talk about compounding interest. Math you will use. You'll use that math if you ever buy a snowmobile. So compounding interest, it's a very, very similar formula. That needs to be memorized. The y equals a times b to the x, right? Like with that and the h and the k, I fully expect you to have that memorized. This formula you need to memorize, and we'll get one more interest formula tomorrow. You need to memorize. They're all very similar, so it shouldn't be too bad. So compounding interest is when interest is paid, so you're getting money. So interest gets paid onto an account that you put an initial amount of money into, but then every time you pay that interest, right, you don't just do it on that account, the money you put in, you do it on the interest that gets in there every time. If I put $500 in an account, and I got 1% on it every month, I would get $5 every month, right? It would be constant. The way compounding interest works is that first month I get $5. Now I have how much? 505 in my account. That next month I get 5% of $505. That's how you start making real money. It's not that, oh, I get $5 every month that goes in there. So I get $5 one month, $6 the next, $7 the next, and it just keeps going, right? So that's compounding interest. So when interest is paid into an account on both the principal and interest. So any interest that's sitting in there, you get interest on that as well. It's compounding interest. So the equation for this, A, and A is just amount of money in an account, right? A equals P, and P is my principal. So already we're like Y equals A times B to the X, right? Replacing Y with A. Replacing B with P, my principal account.
B with B.
All right. 1 plus, we're staying the same there, right? Here's the deal. It's always going to be growth for compounding interest. So it's always 1 plus R over N, we'll talk about that, raised to N times T. So let's go through and label what each of these are. A is just the amount, right? So amount of money. P is my principal. That's the initial amount of money. So I deposited $500. There you go, principal, right? 1 is 1. Really that. R is my growth rate, right? So if I put it into an account and I get 5%, in decimals, that's 0.05, right? So growth rate is important in decimals. Okay. N. This is what's different. T is pretty obvious. T is time. So if I put $500 into account, let it sit for 10 years, T is 10, right? It's almost always in years, all right? But N is the amount of times it's compounded. You'll see in these next problems, I can compound interest in a lot of different ways. I can compound it every day, so compounding daily. So how many times in a year would that get compounded? 365. If I compound every week, how many times, what is my N value? 52. 52 weeks?
Oh, I thought you were saying.
No. No. If I compound every month, what is my N value?
Oh my gosh.
12. Good. There's a little bit of background knowledge in how the Roman calendar works, but I think we should all be good there, right? So N.
I'm sorry. I did not mean to do this.
Are you?
I'm so sorry. That was so.
Where'd it go?
Where did you go?
Alright, N. Number of times per year that it's compounded. Compounded. Bam. That's a C. And then T is just time in years. This needs to be memorized, guys. Yeah.
What if it's not time in years, but it's time in months?
It won't be. It will be time in years. I promise. You'll see. You'll see. We'll do some problems. You'll see how all of this lines up. If I say you'll have to memorize this, I'm also going to say this. In every word problem I give you, all of this information will be here. So if you can just It'll say, hey, the amount is this, the growth rate is this, it's compounded this often, and I want you to know it's going for this many years. So all this information will be there. It's way easier to memorize than you think. Is there a question? I just saw it.
Yeah, it was me. Never mind, I figured it out.
Okay. Good. You deposit $4,000 in an account that pays 2.92% annual interest. Everyone just grow up.
It's not just
Everyone, just grow up. I don't care.
We're in high school.
You deposit $4,000 into an account that pays 2.92% annual interest. Find the balance after 1 year if the interest is compounded with the given frequency. So this is a fair problem that you would get. Usually this will just be one part, and I'll say, hey, and it's compounded quarterly. Tell me how much is in the account. We're going to split it up into A, B, and C. So let's first go through.
But doesn't annual interest mean yearly?
Yes, hold on. Well, I'm going to show you how this works.
Okay.
Stay with me. So let's go through, get our variables. What's my principal?
4,000.
$4,000. Okay. Let's get my growth rate R in decimals.
0.0292.
0.0292, right? 2.92%. Hold on. T. So how many years am I calculating this for?
1 year.
Just one. Okay. And then N. N is going to change, right? N is how many times per year it's compounded. N is going to change for each of these. What is N for A? 4, right? Quarterly. So it's compounded 4 times a year. You've heard of that, the fiscal quarter, and how are we doing on this quarter? Where are my budget reports for the quarter? I know. Daily. What's N? What's N for daily?
365
and then monthly, 12. So that's how N is going to change each time. So let's plug it in. Let's do quarterly to find out how much is in the account. So A equals principal, which is 4,000, times 1 plus, and this is R over N. So R is 0.0292 over N, and we're doing quarterly, so over 4. Raised up to N times T. So N is 4, and T is 1. So we're only doing 1 year here. If I'd asked you to do 4 years, we do 4 times 4. So, and your calculator. How much money is in this account after a year? Your parentheses become very important here.
I got it.
You did not do it.
Yeah.
So what you did is 4,000 times 1, which is 4,000.
Oh,
Right. Yeah, so the plus needs to be inside.
I got you.
You're right to put the parentheses around the 0.0292 over 4, but then you need to add that to 1. Then you need to raise it to the exponent, and then the last thing you do in this whole thing, guys, is multiply it by 4,000. So PEMDAS, parentheses first, right? Then the exponent, then multiply by 4,000. Or that way.
Is that going to be decimal?
What's the rounding on this? What kind of things am I dealing with?
Can't be decimal money.
Money, dollars and cents, right?
100. 100.
Well, the hundredths.
Ooh, this is how much you have.
Nope.
$4,118.09.
I'm hearing it. $4,118. And my rounding got me 9 cents. Order of operations is very important, guys. That 0.0292, the first thing that happens is that's got to be divided by 4. Then whatever that number is has to get added to 1. Then that number gets raised up to my exponent, and then I multiply it all by 4,000. So compounded quarterly in a year at 2.92%, which is very modest. That's like the lowest I would expect. Is about 3% is kind of a good goal, right? I made $118.09. All right, daily. A equals 4,000 stays the same. One, not T. 1 stays the same. My rate is still 0.0292, but now I'm dividing by 365, and I'm still raised to 4 times 1. Still just doing 1 year. It's very close. Because it's, oh, n times T. My bad. Good catch, man. 365 times 1, right? My bad.
I got it.
I got it, guys, I got it.
Give me attitude. No need for this.
How much bigger should this be?
Not much.
Oh, well, sweet, then I got it.
$4,118.52.
Oh, wait, no. That's what I got.
Oh,
Makes sense that it's a bigger number, right? But I would have compounded every single day. I would think it'd be more than what? 43 cents.
You probably just got to raise the amount of years and it'll start gaining quicker.
Yeah. Do month. All right. Do monthly. 1 plus 0.0, 0.0292 over 12. Raise it to 1 times 12. Should be like right in the middle, shouldn't it?
Yeah, like 38 cents.
Yeah.
Is that your cat?
So Lucky's kind of onto something. I would think if I'm compounding every day, I mean, I don't know how much it would be, but I was thinking like, oh, I could make an extra $50 or something. You'd think, as opposed to just 4 times a year. This is just the first year. You are never gonna find a stock option or an account or anything like that. You're never gonna find anything that in 1 year makes you any significant money. Because the best you're gonna get is like a 25% return, right? And over 1 year, not that much, right? It's the difference between compounding quarterly and compounding daily. Right here is about 40 cents, right? Next year, that becomes more like $1.50. The year after that, it becomes exponentially different, right? And so now it's a $5 difference. After 10 years, we're talking about hundreds of dollars in difference, right? Between compounding quarterly and daily. Most bank accounts will compound daily, if not continuously. Continuously is your best bet. We'll deal with that tomorrow. But the more you compound interest, the better it is for you. Who here has $4,000 in an account? I didn't. When I went to college, I worked all summer, and I put this literally could be me. I put $500 in the savings account. I then halfway through college emptied that savings account and spent it all. But let's say on a tuxedo.
Oh, that's awesome.
No.
No,
Tuxedo, and I rented like 4 times for roughly $75 to $100. And I did the math, and I thought I could just pay for a tuxedo. So I did. I just told you.
Music.
So you deposit $500 in an account, it pays 3% annual interest, compounded weekly. All right. Find the balance after 5 years. So you go to college, you work all summer, you make, I don't know, $1,500. You decide I'm going to take $1,000, $50 and everything. I'm going to put $500 into an account, and I'm literally not going to touch it for 5 years. And once I graduate from college, I'm going to pull it out and spend it on, I don't know, something.
Probably a house or something.
Sure, a
I
house.
really think coming there.
I'm more inclined for that. Anyways, so principal, $500, right? My growth rate, R, 0.03. N in this equation, weekly, so it's 52, right? And T, the amount of time, 5 years. Good. Set it up. Go. Solve it. We'll get to it. I thought, like, do you have it? Well, hold on. Well, I'm just tired of walking. I believe you. Good. No, I'm glad. All right, you can come on here.
How many weeks are in a year?
I'm in trouble.
No, I'm serious.
Really?
I'm in trouble. I'm in trouble.
It's okay, Lucky. I thought I was just.
I'm in trouble. How do I know where like the bottom is? Sorry, can I?
What?
0.03 over 1. So you got P, you got your R, and then N and T. So where do N and T go?
I'm guessing that's your. Alright. And then 52 times.
Good.
Is that? Was it 52? I swear, one of these days.
Are you finished?
I'm working on it.
Oh, good. He's done.
He's also getting
Setting it up, A equals
Burger. Oh.
1 plus 0.03 over 52. 52 times 5. So, after 5 years, you haven't looked at your account, you graduate college, your parents buy you a new car,
Yeah, no.
something like that. I don't mind it.
All the way.
You graduate from college, guys, you go, awesome, I'm gonna go get my money. I bet it's like 10 grand, been sitting there for 5 years, and you check it, and you've only made $80.89.
That's right.
Not only is that, and all right, so here's the big question: why the heck would you do this? Why not just pocket the cash and spend it when you need? It's $80.89 you didn't have before. Big deal. 5 years and you only made $80, right? Here's my train of thought. When you put that money into a savings account, you have two things that happen. One, you don't have that money. You can go and get it, but the bank will usually charge some kind of penalty or something, right? So you put it into an account, you're saying, you're basically spending $500. It's gone for, you're saying 5 years, right? Or 4 years or whatever. That money is gone. So when you pull out $580.89, that's not just $80.89 you didn't have. It's also the $500 you didn't have. You didn't have it, the bank had it. It was yours, you could have gone and got it, but you said, I'm putting this away. So you made actually $580. Yeah, so that money's gone. So that's just kind of a principle. That's on principle. Here's the second thing. A bank will charge you money for taking your money out. They'll say like, great, you can get it early, but we want some of it. And so now you've actually lost money. They will never charge you for putting money in it. So here you put $500 in. I don't know, December comes around, you go home, you work a little bit, you come back. After you buy books for the new semester, you got $50 left over. And you say, well, what the hell? I'll put these $50 in here. Okay, that's just $50. That's only going to give me an extra like $1, right? Do that 10 times. How much more do you put in? Another 500. And so it's not just an extra $80.89 because you're compounding interest on that. That's more like an extra, probably $200 or $300. So it works out. It's small scale here. As you get older, it gets larger scale. And your retirement savings, and you're piling up lots of money and compounding lots of money. So, what?